So when a body moves along the circumference of any circle, I repeat, when an object moves along the circumference of any circle, such type of motions are called as circular motion. Such type of motions are called as circular motion, right? Example, if you observe this condition, so this is basically the circumference of an object circle, right? And this circumference has radius, say r. So when an object moves along a circular track, I repeat, suppose we have an object whose mass is m. So when an object moves along the circumference of a circular track, so such type of motions are called as circular motion. When an object moves along the circumference of a circle. So when an object moves along the circumference of a circular track, the motion is said to be circular motion. Motion is said to be circular motion. The motion is said to be circular motion. Clear? I repeat. So when an object moves along the circumference of a circular track, the motion is said to be circular motion. Now there are two types of circular motion. First one is called as horizontal circular motion, and the second one is called as vertical circular motion. I repeat. First type of motion is called as horizontal circular motion. And the second one is called as vertical circular motion. So first one is called as horizontal circular motion. Second one is called as vertical circular motion, right? So basically, what is horizontal circular motion? So when an object moves in a horizontal circle, I repeat, when an object moves along a horizontal circular track, right? Such type of motion are called as horizontal circular motion. In case of vertical circular motion, body moves under the effect of gravity. So if you observe this motion, so this motion is called as vertical circular motion. So vertical circular motion is defined as a circular motion in which an object moves in the effect of gravity. What you can say, under the influence of gravity. It is called as VCM, vertical circular motion. Clear? Example. So when you tie a stone to a thread and you whirl the stone in a vertical circle, it is called as vertical circular motion. Clear? Yeah. So please make a note of it. Please make a note of it.
Yes.
Yes, copied.
Yes, sir.
Done. Okay.
Yes.
Now, see, we have derivation in it. So I will do the derivation. Just pay attention. It's easy, basically.
Okay.
Now, see. Okay. Now, see. Is it visible background? Okay, fine,
Yes,
fine.
sir.
No issue. Now, beta observe, right? So basically, this is a circular motion, right? This is a circular track. We are talking about vertical circular motion. So, motion, vertical circle. Motion in a vertical circle, right? So, suppose we have an object, and this object is moving along the circumference of a circular track in vertical circle. Suppose we have a stone and we connected a stone with a thread and we are whirling the stone in a vertical circle like this. Clear? Under the effect of gravity, this body is moving. This body is performing a circular motion under the effect of gravity. Now, this body is attached with a thread. So the tension will act in the upward direction.
Yeah.
Tension always act away from the object. Second force that is acting is the weight. So weight downward, that is W is equal to mg. W is equal to mg. And we have a virtual force that is acting, that is called as pseudo force. That is centrifugal force. So centrifugal force is always acting away from the center. So tension is acting upward, we'll take it as positive. Weight is acting downward, we'll take it as negative. So let us assume this position as, say, position A. This is position A. So for point A, for point A, that is position A. Position A. So tension is acting upward. So tension is taking, we are taking tension as positive. Weight is acting downward. So we are taking weight as negative. Minus centrifugal force, that is mv square over r equal to 0. Equal to 0. So we can also write this equation as T is minus mg is equal to mv square over r. T minus mg is equal to mv square over r. This is for point A. Now let us assume this position as position B. This point as point B. This one. That is the highest point. So at this particular position, tension is acting away from the body. So tension is acting downward. This is basically the tension. Weight is also acting in the same direction. Weight is also acting downward. So W is equal to mg, mass into gravity. Mass into gravity. And we have a centrifugal force that is acting away from the center. Now, we'll try to balance this equation. So for point B, for point B, for point B, we're talking about this one. So tension is acting downward. So minus P. Weight is acting downward. So minus mg. Centrifugal force is acting upward. So mv square over r equal to 0. So I'm using a small suffix mvb. vb means velocity at position
B.
Now, what we can do, we can just bring this term towards right hand side. It will change its sign. So T plus mg is equal to mv square over r. mv square over r. Now, when we talk about tension at the highest position, at highest point, tension is always zero. So there is no tightness in the spring at the highest position. So at highest position, tension is zero. So at highest position, tension in string, tension in string is zero. Tension in string is zero. So if I substitute the value of tension as zero in this expression, so the expression will reduce to mg is equal to mvb square over r. mvb square over r. We can cancel mass from both the sides. Just simply multiply g with r. Multiply g with r. That is nothing but vb ka square. So vb is equal to what? Root of g into r. vb is nothing but root of gr. That means at highest position, the velocity of an object at this position, the velocity of an object is root gr. Root gr. At highest point, the velocity is root gr at this position. Root gr. This is velocity at position B. Velocity at position B. I hope the concept is clear.
Yes, sir.
इसको कॉपी करेंगे बेटा.
Yeah.
I will increase the size. Yeah, please copy this.
Oh,
Can we
so
done with it?
yeah,
This one?
yeah. No, after write the. Yeah. Yes, sir. Done.
Done?
Yeah.
Okay, next one. So velocity at point B is root gr. Clear? Now
Yeah.
next target is to find the velocity at point A. We want to find the velocity at position A. So velocity at point A. Velocity at point A. So we'll use a concept of conservation of energy. That means change in kinetic energy is equal to change in potential energy. Change in kinetic energy is equal to change in potential energy. So kinetic energy at point A minus kinetic energy at point B is equal to potential energy at point A minus potential energy at point B. What is kinetic energy at point A? Kinetic energy at point A. So it is nothing but half mVA का square. So formula is half mVA का square minus half mVB का square is equal to potential energy at point A. What is potential energy? So height is 0. If I take this as a reference point, so at this position height is 0. So potential energy at point A is 0. While potential energy at point B, the formula is mg into height. And what is height basically? Height is this distance. So if radius is r, so it will be 2r. So height is basically 2 times of r, mg into 2 times of r. Now next step, just take m as common. It will get cancelled out. So we are left with 1 by 2 in the bracket. VA square minus VB square is equal to 2 times of R into G. 2 times of R into G. Now substitute the values. Substitute the values. So velocity at position B is what? Root GR. So if I multiply this 2 with 2, that is 4 times of RG. And we have VA ka square minus, what is VB ka square? VB ka square is root GR. Root GR. So it is GR. VB is basically root GR. So VB square will be GR. So if I bring this GR from left to right, it will change its sign. So VB ka square, VA ka square can be written as GR plus 4GR, which is nothing but 5 times of GR. 5 times of GR. So VA is nothing but root of 5GR. 5GR. So this is the velocity at position A. Root of 5GR. Root of 5GR. It is important to note that the velocity at lowest position is nothing but root times 5GR. At highest position, it is root GR. So in the mid one, in the mid path, if I consider this for this position, so at position C, it is root 3GR.
Okay.
I repeat, at highest position, it is root GR. Lowest position is root 5GR. At the mid portion, it is root 3GR. Root 3GR. Hope the concept is clear.
So can you just explain the potential energy part?
Okay.
How-
Okay. Now see, basically we want to find the change in potential energy. Potential energy is basically mass into gravity into height. So if I take this as a reference point, this point as a reference point, so at this position height is 0. That means potential energy